Okay, today we're going to be talking about weather forecasting, all the different types of terms of weather and all things that meteorologists need to know about when they're making a weather forecast. You could see the NOAA, the National Oceanic and Atmospheric Administration, they issue warnings, and they have satellites and radars. They notify the National Weather Service. We have one in Mount Holly, New Jersey. And then it goes to the Climate Prediction Center, where they can make better predictions in the future based on what would happen in the past, and they send it to the Hurricane Center and the SPC in Norman, Oklahoma, where they issue the tornado warnings. That's where the Storm Prediction Center is. Also, they make weather forecasting, and then they send it out to the public. Weather is sometimes they hype it up. That's bad for businesses if they have a state of emergency and they close down the state because everybody stays indoors when there's a storm. But it's great for like grocery stores and gas stations because everybody goes to the grocery store and they stock up, and then they go to the gas station and they fill up their cars and snow blowers and power chainsaws if there's down trees or hurricanes. There are over 10,000 weather stations, observatories, weather stations, datas and buoys in the world that collect weather data all over the world. There's different types of weather forecasts. There's a persistent forecasting, like if there's a nor'easter or a hurricane, you're going to get nor'easters. It's going to be snowy for a long time, for 2 to 3 days. If it's a hurricane, you're going to get rain for over and over, inches and inches of rain. So it's persistent because it stays over the same over like Arizona. They might have a hot spell, a dry spell, so it could be 110 degrees every day and sunny and very dry. So that's persistent weather. We have climatological forecasting. That means data over at least 30 years of data. They also have napcasting, or trend, which is the next few hours, like 2 to 5 hours. They heavily depend on the radar, because if it's a thunderstorm now at 2 o'clock in the afternoon, it's probably going to be still raining at 5 p.m. So they depend on the radar, especially during tornadoes. They see if they have a debris ball or a debris signature to see if there's a tornado spotted, and you can see where the hail in the tornado is the greatest at the place. Also, they look at different surface levels in the atmosphere, like 850 millibars are horizontal, and from the air and the space, that's where the satellites look down at the clouds and the radar, and they see, because it could be down here, it could be raining, and it could start off as snowing in the upper atmosphere because it gets colder as you go up in elevation. At 250 millibars, this is where you could see the jet stream in the trough right over here. Right here, an isotac is an equal line of isobars right here. When the bars are closer, you're going to get more stronger winds, especially during a hurricane. They say 951 millibars during Sandy, so that means we had 80-90 mile per hour winds. But if you're more spread out, like on a nice summer day, you're going to have to be like 130 millibars, so you're going to have calm winds that day. And usually weather forecasters don't pass beyond 7 to 8 days because very low accuracy. 1 to 2 days they have high confidence. 3 to 5 they have somewhat medium confidence, and past 7 to 8 days they could say it's going to be a big nor'easter next week, and it could change and go out to sea after 8 days. They can barely get it on 2-3 days how accurate it's going to be. So 8 days you should barely even be looking there. In the 1960s, that's when they launched the first weather satellite. You can see here the different types of fronts. You can see a cold front moves quicker and it brings cooler weather. Warm front brings a warmer weather, and it brings drizzly weather followed by clear weather. The stationary front, it doesn't have enough force to move, so it lingers on the same area for days, and it brings many days of cloudy, wet weather. And then also here's a occluded front, which brings cool temperatures and large amounts of rain or snow for days, for a while. You can see here the different types of cells and winds we have on Earth. You can see right here is the polar cell right here, the Ferrel cell right over here. See the Hadley cell, the equatorial low, or the ITZ. That's where you get most heating right over here. Subtropical high over here. You get most of our weather from the westerly winds, because all of our weather meteorologists look from California, because all the weather comes from California, and then eventually it heads to our air, because of the Coriolis effect. That's the way the winds travel. Here, this is an isotherm map, which it's an equal line of temperature, and you can see right over here 71 degrees. So right in here in the red, You have 71 degrees, then you have 60 degrees right here, and 45 degrees right over here, 30 to 40 degrees, you get some cooler weather over here, and then Arctic air right over here near 10 to 20 degrees right over here. This is nice therm map, equal lines of temperature. You could see there's different types of models that the National Hurricane Center uses. This is one example because they usually always get the models wrong. European, sometimes it says it wants to take it inshore, and then the American model wants to take it out to sea. Then there's the Canadian model that hypes the snowstorm up, and then there's the reliable model that I think is the NAM. It nails the snowstorm every time. So you can see this is projected all over the world. It's like spaghetti models and spaghetti plots. Hurricane forecasting, because nobody knows where the storm's going to go, because like that one storm they said there was going to be a big hurricane heading up. It's going to go up here, and then it's going to make an unusual turn back to Florida. It didn't do that. It just went out to sea. And they're also called ensemble models, forecast models, and they use the runs over using the same model over and over again. So like the American model, they keep shifting it slightly, so just in case the 2 o'clock advisory from the European model says it's going to go to New Jersey, but then 2 hours later it's going to go out to sea. They spread it slightly as it keeps going, as they're more confident, because they're not going to go here, then they're going to go back to here, back and forth. That's what this model's looking at. That's what they use, trend of the same model over and over. The model runs over the past few days. You could see here's the visible satellite, the radar. You could see this is from the satellite from on Earth. You could see the cloud coverage right over here in the US. This is only visible only in the daytime, because after nighttime you can't see the clouds from the radar after the sun goes down. You could see here's the water vapor imagery of this hurricane. You could see there's lots of water vapor over here, so that's why there's lots of moisture over here during fueling the hurricane. Here's the infrared. Here's the heat of the hurricane. You can see how much fuel's in the storm. The more heat you have, the more precip you have. Thermo gun, you can see how much thermo energy is right over here. Okay, you can see here we're going to show you some other weather terms, and they use in meteorology. You probably heard of this. If there's like a nor'easter or a hurricane, you probably heard bombogenesis or a bomb. The criteria for that, you have to have low pressure, close isobars. They have to be really close, and it has to drop at least 24 millibars within 24 hours. Strong, rapid intensification. You can see lake effect snow. You probably heard of this before. Maybe not much here, but probably near New York, near Buffalo, New York, because they're right next to Lake Erie and Niagara Falls. You could see you have high pressure right over here, very dry. Then it goes over this like lake that's very warm, because it takes a lot longer for the lake to cool down. So then you have warm moisture coming up and creates steam fog, because you have cold air but warm waters, so it creates steam fog, and then you get some low pressure, humidity, and cool air, so that creates snow. Usually they don't dump a lot of snow, but that one year, 2-3 years ago, Buffalo, New York, they got hammered with 10 feet of snow. Usually they only drop a few inches, so they sometimes lake effect snow. They could be a big surprise on you. This term is not used too often. It's well, we don't hear it in the Northeast, so usually in the West they hear, because a Pineapple Express, it usually is from Hawaii and it goes towards California, brings lots of moisture from the jet stream. It drives the winds in deep tropical moisture. It brings heavy rain and winds for the West Coast. Here this is called the MJ, or the Madden-Julian Oscillation. You probably heard Brian Norcross talk about this on the Weather Channel during hurricane season. I'm not too sure what it is. It's like El Nino and La Nina. It tells you the favorability of a hurricane forming over the next few weeks, over the temperature and the winds. The wind shear is going to destroy the storm if it's favorable for creating hurricanes. Also, there's different types of clipper systems. Right over here, this is, you usually hear this one, an Alberta clipper. It comes from Canada. It comes down into the New Jersey Northeast area. Then there's also a Saskatchewan screamer that comes down and comes and hits us. And then there's also a Manitoba mauler that comes and hits us right over here. There are different types. They're just different types of names from the origin of where the storm comes from Canada, and they usually dump only 1 to 3 inches. That one year they hyped it up and say we're gonna have 18 inches. Usually they don't produce too much snow unless it bombs out over here with low pressure and negative trough, a blocking high. You're usually not gonna get too much snow.